Okay, so we're going to look at some partial derivatives, and we're going to find these four partial derivatives here. The second partial with regards to x, and here we've got the second partial with regards to y. Then here we've got two partial derivatives that look very similar. Partial derivative with regards to x and then y, and then the partial derivative with regards to y and then x. And then we're going to see if we can draw any conclusions from our answers. Now our f, which is our function here, is x over 1 plus y squared. So x and y are our two variables that are of interest in this question, and we know nothing about either. So first thing we can draw is that y squared cannot be a complex number. So y squared, y cannot be I, otherwise this numerator, so this denominator would be 0. So that would be no good to us there. So we're definitely dealing with real numbers. So let's have a look at this first partial here. Let's have a look at this one first. So the partial of f twice or squared with regards to x. Now I prefer to rewrite this, because it's sometimes easier to understand, is the partial with regards to x of the partial of f with regards to x. So basically what we do is we take this partial first of f and take that with regards to x, and then the answer of this, we take the partial of that answer in here. So let's jump straight into that. So that's now the partial with regards to x, and then the partial with regards to x of our function, which is x over 1 plus y squared. Now this x over 1 plus y squared, the x is the variable of interest, and the 1 over 1 plus y squared, which is what we've got here, because we could put an imaginary 1 here, and we could write that as x times 1 over 1 plus y squared. That would be the same as what we've got here. Our partial is only with regards to x. So in terms of this part of the question, this is just a constant. So if you take the partial of x, well, the partial of that just becomes 1, and then we're just left with this. So our next line of working would be partial with regards to x, then this here just becomes this. So then we're left with 1 over 1 plus y squared. So we've taken the partial with regards to x, and we're just left with this, which is our constant with regards to x. So now taking the partial of this with regards to x, well, now this whole thing is just a constant, and there's no x term. So now this will just end up giving us 0. Take the derivative of any constant, you always end up with 0. So we can take this one off the board now, and just write underneath that this one just equals 0. So that's our solution there. Let's have a look at the one with regards to y twice. So let's do that. So the second partial of f with regards to y. Okay, so rewriting that as we did before, we do the partial with regards to y of the partial of f with regards to y. So now we can plug this in for our f as we did before. So the partial with regards to y of the partial with regards to y of our function, which is x over 1 plus y squared. Okay, now a way to help us with this, we could write this as x times 1 plus y squared to the minus 1, because this minus power is going to be pretty important to us. Otherwise we're going to end up with the wrong polarity of our answer. We could end up with a positive rather than negative. So now with respect to y, we're taking the derivative of this with respect to that. So we can use the chain rule inside this bracket, in this bracket here. So this minus 1 will come out front, and that will then give us minus x. X is just a constant. We're taking derivative with regards to y, so that will just end up with minus x. And then by the chain rule, we want the derivative of the inside of this, which is 2y. So that's the 2y, and then leave the 1 plus y squared. and then by the power rule this will then decrease by 1, so then this will become minus 2. So now we can say we've got our partial with regards to y, and now what we're left with here now is minus x times 2y, so we can just write that as minus 2xy, and then 1 plus y squared to the power of minus 2 is just 1 plus y squared in our denominator and squared. Okay, so we're going to take the partial with regards to y, so this minus 2x is just a constant multiple, so let's bring this out the front and then take the partial of the rest with regards to y using the quotient rule. So let's do that. So this then equals minus 2x partial with regards to y of y, so the minus is now gone out front, we can do that, and then we've got 1 plus y squared squared. So let's take the quotient rule. So we've got minus 2x, that will stay, and now what we can do is set up our fraction. So we've got 1 plus y squared squared, that's fine, and then with the quotient rule we will square this again, so then we can just bring this to the power of 4, that's fine, and then what we do is we take the derivative of y and bring the denominator up. So we want the partial of y, which is just 1 times 1 plus y squared squared, and then we subtract. Our y will stay, and then we multiply that by the derivative of 1 plus y squared squared. Well, if we put our brackets around our y, take the derivative of this, 2 will come out front by the power rule, and then 1 plus y squared. The squared will then be reduced by 1, so that then becomes just like that, just a 1, and then the derivative of the inside will be 2y. So that's our chain rule. So now let's bring this back up top here and simplify things off a little bit. So we've got 1 times 1 plus y squared squared with the minus 2x. So we've got minus 2x, open bracket, 1 plus y squared squared. So that will be taking care of that. And then we've got minus 2y and 2y, so that's 4y squared. So that's going to be minus 4y squared. That takes care of them. And then a 1 plus y squared again. And then that's all going to be over. Let's just make sure we distribute this 2x properly. 1 plus y squared to the power of 4. Okay, that's our equals. Okay, right, now let's just distribute this minus 2x and then see if we can do something to simplify this off, maybe splitting the fraction. Okay, so minus 2x we can bring inside here, but then we've got 1 plus y squared squared and a 1 plus y squared to the 4. So we can just rewrite this as minus 2x over 1 plus y squared squared. So obviously these two can cancel out and just leave us with squared in the denominator. Now we distribute the minus 2x with the minus 4y squared. So we got plus 8 and then xy squared. And then if we do the same again here, 1 plus y squared, 1 plus y squared to the 4, we can just reduce this down to the cubed. So that's 1 plus y squared cubed. Okay, now what we do is if we could multiply top and bottom of this by 1 plus y squared, we get the same denominator. So we can make this then back to one fraction. So as we got a minus at the front, I'm just going to bring this one into first place here. So that's 8xy squared minus, and then just setting up my denominator, 1 plus y squared cubed. So if I multiply top and bottom here by 1 plus y squared, that serves the purpose of getting my denominator correct. But now I need to multiply this by 1 plus y squared. So if I just write that there, and obviously I've got to put 1 there as well. So that's eventually the effect of multiplying by 1. Put that there, multiplying by 1. And now, okay, so distributing, we've got minus, and then 2x plus 2xy squared. Okay, so now we can simplify this even more. We've got an 8xy squared and a 2xy squared here. So let's just try and simplify off even more. So we've got our minus 2x and our minus plus 2xy squared. So that becomes minus 2xy squared. And we've got a positive, let's just put a positive there. A positive 8xy squared. So that then becomes 6xy squared minus 2x over 1 plus y squared cubed. There we go, that's our partial derivative for this one taken care of. So let's just see if we can just fit that in up there. So I'm just going to just rub this out a little bit now, and I'm going to write our answer in here. So we've got, for this one, we've got 6xy squared minus 2x. So we can even factor out even more. We can factor out a 2x. So we've got a 2x with 3y squared minus 1. So that will multiply out to give us that, the same. And then that's divided by 1 plus y squared cubed. So that's that partial taken care of. Okay. Now let's have a look at these last two here. We're going to run these two simultaneously. So partial squared f with regards to x and then y. And then just further down here, I'm going to write this one, which is partial squared f, partial of y, and then partial of x. So as I did in the previous two examples, I'm going to rewrite these as the partial with regards to x of the partial of f with regards to y. And I'm going to do the same for this one. So now that's the partial with regards to y. So we're going for a different side here. And then the partial of f with regards to x. So that's still giving us the same things, but different way about it. So let's see what happens here now. So the partial of f with regards to y. So, and the partial of f with regards to x. Now we've done these a little bit already. So we could say now the partial with regards to x, partial of f with regards to y. That one was minus 2xy over 1 plus y squared squared. So that was that partial there. We did that previously. And now this one, we've got the partial with regards to y, and then the partial of this with regards to x. We know x was the variable we're going to differentiate, but the 1 over 1 plus y squared was the constant multiple. So this just leaves us 1 over 1 plus y squared. Okay, let's see what we can do here now. So the partial with regards to x. So the minus 2x, this can come out front, and then we're left with y over 1 plus y squared squared. So if we're taking the partial of that with regards to x, this will cancel out, and then this will become a constant multiple. So it will leave us with minus 2y over 1 plus y squared squared. That's our partial there with regards to x and then y. So that's this one. So this one, if you take the partial with regards to y, remember this is 1 plus y squared to the minus 1. If you take the partial of this, we end up with minus comes out the front, and the 1 plus y squared, we take the derivative of that with regards to y, which is 2y, so that's minus 2y, and then 1 plus y squared to the minus 2, using the power rule. So that equals minus 2y over 1 plus y squared, just write that squared a little bit tidier. So these are in fact the same partial derivative. So this one and this one are equal. So let's just put them in a nice little circle so you can see those. They will both give you the same answer. Obviously this one as well. Okay.